Welcome to Brain Vision.
So here we're given examples of strong base solutions. And since the concentrations of our strong base solutions are relatively large, we can assume that autoionization of water is not significant and dissociation is complete. So we have 0.15 molars of a monoprotic strong base, sodium hydroxide. So the concentration of hydroxide would just be, since there's complete dissociation, is 0.15 molars. And as a result, we can determine the pOH first. So the pOH is the negative log of the concentration of OH. So this is equivalent to 0.82. And the pH is 14 minus the pOH, which is equivalent to 13.18. And our concentration of H plus is 10 to the negative power of our that, and we find that this is equivalent to 6.6 times 10 to the negative 14 molars. And we're going to repeat this process. So we have a 1.5 times 10 to the negative 3 molar concentration. However, this is for a diprotic base, so the concentration actually doubles. So instead of 1.5, it's 3 times 10 to the negative 3 molars. And once again, we have complete dissociation. And our pOH, negative log of that, which is equivalent to 2.52. Our pH is 14 minus that, which is 11.48. Our concentration of H plus, 10 to the negative log of that, is equivalent to 3.3 times 10 to the negative 12 molars. And in part C, we have 4.8. Once again, we have a diprotic base, so actual concentration due to hydroxide, there's 2 moles of hydroxide produced per 1 mole of the base, so it actually doubles. So this is equivalent to 9.6 times 10 to the negative 4 molars. And then once again, we can find our pOH, which is equivalent to 3.02. pH is going to be equivalent to 10.98. And the concentration of H plus is 10 to the negative pH, which is equivalent to concentration of H plus is equivalent to about 1.0 times 10 to the negative 11 molars. And last part, we have a monoprotic base. Concentration of OH minus would just be the concentration of the base due to complete dissociation. Once again, we're interested in finding our pOH, negative log of that. And this is equivalent to 4.06. pH would be equivalent to 9.94. And our concentration of H plus is 10 to the negative pH, which is equivalent to 1.1 times 10 to the negative 10 molars. And this gives our final answers.